Welcome to aminacademy.com. In discrete mathematics, regarding mathematical induction, let us do some solving problems. Look at this example. Use the mathematical induction to show that 1 plus 2 plus 2 square plus 2 cube plus dot 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 plus 2 power n is 2 power n plus 1 minus 1 for all non-negative integers n. We have to prove this expression by using mathematical induction. For this, the basic step. First, we have to write the given expression, that is p of n equal 1 plus 2 square 2 cube plus 2 power n equal 2 power n plus 1 minus 1, as it is we wrote. Now, for the basic steps, you have to substitute n equal to 0. What happened here? P of 0, here p of 0, here there is no n, here n is there. Therefore, 2 power 0. 2 power 0 is 1 we have, and right side is 2 power 0 plus 1, because n is 0 plus 1 is there. Therefore, which is equal to power 1. 2 power 1 is 2, minus 1 is 1. So, left hand side is equal to right hand side. So, the basically this is true. For induction, first step is true. Now, inductive step. Let n equal to k for non-negative integer. We have to substitute n is k, that is p of k equal 1 plus 2 plus 2 square plus 2 cube up to 2 power k. We are substituting here, and which is equal to 2 power k plus 1 minus 1. Here, for the inductive hypothesis, we assume that p of k is true for any arbitrary non-negative integer k. So, we have this expression. Now, therefore, you can write left hand side is 1 plus 2 square plus 2 cube up to 2 power k plus 2 power k plus 1. Means here we are next is we have to substitute n is k plus 1. That is adding 1 for k. It's also true for this inductive step. That is p of k plus 1 is 1 plus 2 plus 2 square plus 2 cube up to 2 power k plus 1 equal right hand side is 2 plus k. Instead of k, we are using k plus 1. Another one is there, so k plus 2 minus 1. Now, therefore, you write left hand side is 1 plus 2 square plus 2 cube plus dot 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 plus 2 power k plus 2 power k plus 1, which is further equal. You are getting this one expression, and this is the another expression, that is 2 power k plus 1. Now, look at here. This is already we have 1 plus 2 square plus 2 cube of 2 power k is this expression, that is 2 plus 2 power k plus 1 minus 1. We are writing here, and another 2 power k plus 1. Here, opening the bracket, we are having 2 power k plus 1 is 2 times, that is 2 into 2 power k plus 1 minus 1. Here, 2 can be written as 2 power 1, means which is for applying indices rule, that is 2 power 1 into 2 power k plus 1 is 2 power k plus 2, that is 2 power k plus 2 minus 1, which is equal. Therefore, you can write 1 plus 2 square plus 2 cube plus 2 power n is 2 power n plus 1 minus 1. So, therefore, we can write therefore this we can say, hence we have completed the inductive steps. Therefore, all are true here, all steps. All steps true, therefore hence proved. Let us do one more problem. Use mathematical induction to prove the sum of finite geometric series, that is sigma j equals 0 to n a r4j. This is the expression for geometrical sum of the geometrical progress series, which is equal a plus ar plus ar square plus ar cube plus dot 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 ar4n. This is the expression which is equal a r4n plus 1 minus a by r minus 1, where r is not equal to 0. Here where n is the non-negative integer, r is common ratio of this expression, means ratio of this second step to first step or third step to second step, like that. A is the first term. Now p of n equal, expressed in terms of p of n is equal a plus ar plus ar square plus ar cube plus dot 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 ar4n, which is equal a r4n plus 1 minus a over r minus 1. We are expressing this one more time here in terms of p of n. Now for the basic step, basic step equal, put n equal to 0 in this expression, p of 0. Here there is no n term, and which is equal a r power 0, because n is 0, equal a r power 0 is 1, with 0 plus 1 minus a over r minus 1. Here anything for 0 is 1, so a into r power 0 is a. This side, look at here, this is a r minus a over r minus 1, taking a common, that is a into r minus 1 over r minus 1. The r minus 1 factor cut, so we have a. So left hand side also a, right hand side is also a. Therefore inductive steps proved. Now take any some arbitrary constant, non-negative constant k. We are writing the given steps, that is a plus ar plus ar square plus ar cube plus dot 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 ar power k, and put, that is ar k plus 1. That means r power k is previous step and ar k plus 1 is the next step. Next here, look at here, this which is equal a r k plus 1 over r minus 1 plus a r k plus 1. This we are writing. This expression is here, and this we step, second step here. Look at here, we have this denominator r minus 1 factor, here no factor, that is cross multiply, that is multiply and divide by r minus 1 factor, that is r minus 1 over r minus 1, we are multiplying and dividing. Now write here a r power k plus 1 minus a over r minus 1. This side multiply this r with a r k plus 1, that is a r k plus 2, because r power 1, this is k plus 1, that is k plus 2 here, and minus 1 into this one is minus a r k plus 1 over r minus 1. Here r minus 1 is a common denominator, write this, and this, therefore a r k plus 2, this cut here, this terms cut because negative and positive. Then we are writing a r k plus 2 minus a over r minus 1. Therefore here inductive steps is proved. Here inductive step proved. Therefore we can say this combining the last two equations, we have this relation, that is a plus ar plus ar square plus ar cube plus dot 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 ar power k plus ar k plus 1 equal ar k plus 2 minus a over r minus 1. So all steps are proved, hence the relation is proved, hence proved. You have done. Please subscribe our YouTube channel.